Okay, so in this section, we're going to talk about scientific notation. And I know some of you have already done this, which is awesome. Just hang on and watch the video. If you're new to scientific notation, we're going to start at the beginning. We're going to go through it all together. And if you're okay with it, you'll get something out of this too. All right? So let's start at the beginning. Scientific notation, along with an understanding of significant figures, is a way to take very large numbers or even very small numbers and make them easier to read and write. By understanding and using these two concepts, you will be more prepared to know the answer to the question, how many decimal places should I round to? We will use both concepts throughout the rest of this year and next year in chemistry. We will deal with very large numbers and very small numbers. For example, the mass of an atom of gold is this tiny, tiny number. That's 0 point a bunch of zeros and then 327 grams of gold. If we look at a really big number, we have 1 gram of iron. 1 gram of iron contains this huge number of atoms of iron. So in chemistry, you can see that we're going to need really big numbers and really small numbers. So scientific notation is going to help us to put these numbers into more manageable numbers. All right, so scientific notation will allow us to take this very tiny number and make it a more manageable number. And they both give us the same amount of information if you know how to use scientific notation. Scientific notation will allow us to take this very large number and make it more manageable into this one. And again, they mean the same thing. With significant figures, we'll be able to determine how many decimal places we need to include. So for example, should we have put all of these numbers in here or should we only put a few? After we finish this chapter, you'll know what to do. Scientific notation is 2 parts. The coefficient is a number between 1 and less than 10. So if we look at this as our first example, the 5 is our coefficient. It's a number that's between 1 and less than 10, so 9 point something, all right? The exponent is usually 10 raised to a number, and the example here is it's raised to 2. These 2 parts are linked together with the multiplication sign. So this is scientific notation. And if you take a look up here, these are very similar. They have a coefficient, which is more than 1 but less than 10. They have times 10, and then they have a number which can be positive or it can be negative, raised to some exponent. How to take a number out of scientific notation. You have 2 options for the exponent. It can be either positive or negative. So 5 times 10 to the second, that has a positive exponent. To take this number out of scientific notation, you identify where the decimal point is. So let's do that first. So 5, where's the decimal point? Yeah, it's to the right of that 5 times 10 to the second, okay? And if the exponent is positive, you move it meaning the decimal point, to the right that many times. So we're going to move it over 1, 2, all right? So now if we moved it over from 5 and we moved it over 1, 2, now it's going to be 500. In this example, you would move it to the right 2 places, which would make the number 500, just like we did. If the exponent is negative, you move to the left. For example, 5 times 10 to the negative second, so it's a negative 2 up here. First, you want to identify where is that decimal place. Yep, it's to the right of the 5. And now you take that decimal place and you move it to the left 1, 2. So when you move it to here, you have to add that 0, and now it would be 0.05. You could also write it as 0.05. That 0 is optional. And again, we're going to talk about zeros being optional and required later on in this chapter. Okay, so that was moving it over. So do you need that first 0 on the left? Nope. When we define significant figures, you will learn when zeros are needed and when they are not. Okay, so hopefully that helped you with positive and then with negative. All right, let's try a couple problems. If the number is in scientific notation, take it out. If the number is not in scientific notation, put it into scientific notation. All right, give it a try. Pause the video. Hit the pause button. Thank you for pausing the video. All right, let's take a look at the first one. So here we have this number that's clearly not in scientific notation. How do we put it into scientific notation? Great answer. Yeah, exactly. So we take this decimal point, and remember, what are the rules with scientific notation? It needs to be something that's greater than 1, but less than 10, raised to something, and that could be positive, it could be negative. So we need to make this 0.00562 number, we need to make it larger than 1, but less than 10. So let's move it over a couple times and see what happens. So it's here, and then we move it 1, 2, and then 3. And that's going to make it 5.62. And that number is greater than 1, but less than 10. So that's perfect. So now we're going to do times 10. And the question here is it going to be a positive or is it going to be a negative? And if you think about it, we went to the right here to put it into scientific notation. So if we wanted to take it out of scientific notation, we would have to move it to the left, right? And what we said before was if you're moving it to the left, that means it's going to be negative. So this would be a negative. And again, let's double check. It started here, 1, 2, it ends here, so negative 3. So our answer would be 5.62 times 10 to the negative 3. All right, good job if you got it. Now let's look at the next one, B. We have 5,000 here. Where's the decimal place for this one? Yeah, exactly. The decimal place is after the 1. So it's over here to the right of the 1. And we need to make this 5,000. We need to make it all the way down to 5. So in this case, we moved it also 3 times, right? So now it's going to be 5.001 times 10. And in this case, because now if we wanted to take this out of scientific notation, you would move it to the right. This would be positive. So it's going to be to the third. All right. Another way to remember if it's negative or positive is if you start with a number that's less than 1, it's going to be negative. And if you start with a number that's greater than 1, it's going to be positive. All right, that's kind of like a quick, easy way, and it works almost all the time. All right. Okay, let's check out C. So C, we're taking it out of scientific notation, and it's negative. So we said negative. All right, negative goes to the left. It's going to go to the left 3 times. So it starts here, and it goes 1, 2, and then 3. So we need a 0 here, and then a 0 here, and then the decimal. So it's going to look like 0.002018. And that's going to be our answer for that one. You can have the 0 in front if you'd like. All right, last one. Now for this one, which way is the decimal going to go? Is it going to go to the right or to the left? Because it's positive, it's going to move to the right. 1, 2, 3, 4, 5, 6 times. And that'll give us this number here. Let's double check it. 1, 2, 3, 4, 5, 6. Good. So it's going to be 4, 4, 5, and then 4 zeros. All right, and we can put some commas in there so we know what the number looks like. 4,450,000 is going to be our answer for D. Now here's a tricky one. What if they say put 5.23 into scientific notation? Well, it's already a number that's between 1 and less than 10, right? So you're like, I'm done. Technically, it's not in scientific notation, since the format also needs times 10 to a exponent. So here we have the coefficient, 5.23, times 10. Times 10 to what is going to make it the same number? If you said 1, well, think about it. All right, that's a 1, right? So that means the decimal is going to move 1 time over. That's going to give you 52.3, which is not the same number. What else could it be? Yeah, exactly. It's going to be 5.23 times 10 to the 0. Because, and you can try this in your calculator, if you put 10 to the 0 power, that's going to make this 1. And what's any number times 1? The same number. So that would give you the same thing. So this would be your answer for that kind of weird trick problem. And it comes up sometimes, which is why I'm showing you.